Good evening. So in my Teach the Doc, Chapter 1 for Measurements and Dimensional Analysis, I'll go ahead and read through my answers. So starting here for number 1. Now, what is the difference between a pure substance and a mixture? And giving 2 examples. Now, a pure substance has a constant composition. For example, elements such as gold and oxygen are pure substances, as well as a compound such as water, H2O, which we'll cover in the next question. And then a mixture is a combination of substances which can be separated by physical methods. This could be carbonated beverages, salt water, or sugar water. Now, what is the difference between an element and a compound? And give 2 examples of each. Now, an element cannot be broken down into smaller substances chemically. And examples of elements would be sodium or antimony. And then a compound can be broken down into smaller substances or into the elements that form that given compound via chemical changes. Examples of compounds would be water and H2O or carbon dioxide and CO2. Now, what is the difference between a homogeneous mixture and a heterogeneous mixture? Give 2 examples of each. Now, a homogeneous mixture is a mixture which has a uniform composition in the entire substance. An example of this would be sugar water, salt water, or carbonated beverages before they're opened. And then heterogeneous mixtures are not uniform throughout their composition, and the composition is inconsistent throughout the entire substance. Examples of this would be sand and water or carbonated beverages after being opened. Now, moving on to physical and chemical properties and changes. Now, what is the difference between a physical property and a chemical property? And giving examples. Now, a physical property are the aspects of a specific substance which aren't associated with any changes to the substance's overall chemical makeup. 2 examples of these would be bending a substance or dissolving a substance in another. A chemical property is when a change is made in the fundamental chemical properties of the original substance. 2 examples of this would be when burning a substance or the rusting of certain substance. Now, this next question kind of goes back into that previous one of what is the difference between the 2, physical and chemical changes. Now, a physical change is a change that does not affect the chemical composition of a substance, whereas a chemical change will affect the chemical composition of a substance. My second example was one of a nail for use for carpentry. Now, if a nail is being melted down to be reused for some other purpose and it's still that same metal, then that's just a physical change. However, a chemical change would be if that nail was rusting and the metal itself was changing its chemical properties. Now, my first example I used in this answer is that of water. Now, if you freeze or you melt water or you boil water and it evaporates, then that water won't change its chemical properties, it just changes its physical form. Whereas if you were to say have an electric current pass through it and then the molecules would change from H2O to H2 and O2 separately, then that would be a chemical change. Now, for these on the density, I'll go ahead and increase each size as I talk about them. But calculating the density of iron, so for this we just have the simple equation of density is equal to mass over volume, and we have the given volume of 27.6 centimeters cubed and the mass of 74.6. You calculate that to find the density of 2.70 with 3 sig figs. We then go down to the next question of what is the mass of 6.00 centimeter cubes of mercury. Here we plug in the density which we are given, and we have the volume of the mercury. We multiply the volume over times the density to find the overall mass of the mercury, with those 3 significant figures given to us from the volume. We do the same thing here, although this one just had some calculator. Same thing here, where we have the 0.702. You multiply it times the 225.0 milliliters to get the 17.6 grams. Here we switch it up and we're looking for the volume. So in this one, we have the density, we plug that in. We have the mass, so we plug that in. And so this time we would multiply the x, or the volume, over, and then we would divide by this the density to find the volume. So we would divide both sides by the 4.93. So we divide 25 by the 4.93 to get the 5.07. Here we do the same thing where we are multiplying the volume times the given density to then divide the given density by on both sides to find the volume. Then here, when converting from meters to kilometers, we find that we are given the conversion of 1 kilometer is equal to 1,000 meters, and so therefore 1 meter is equal to 0.001 kilometers, and 75 meters is equal to 0.075 kilometers. There we go. And then for this here, we have a similar concept. We're going from 16 centimeters to yards. We know that 91.44 centimeters into yards. For this one, I set it up as a ratio of doing 16 centimeters, left out my units there, over 91.44 centimeters is equal to x over 1 yard. You would then multiply the 1 times the 16 divided by the 94, or 91.44, and then multiply times the x. And you would then end up with the 0.1749. Then here, for the significant figures, here we only have 2 significant figures. Here we have 3 significant figures followed by the zeros afterward, which are insignificant. We have 2 numbers with 2 captive zeros, so it's a total of 4. We have 1 number, 2 captive zeros, and then 3 more significant numbers, so it's a total of 6 sig figs. Here, these are trailing or leading zeros, so these are insignificant, so we only have 3 here. Here we have 5, as we have more leading zeros. Here we have 4 significant figures, as the smallest decimal goes to places in, and the largest whole number is 2 digits, so it's a total of 4. And here, the lowest decimal is only 1 decimal place, and the largest whole number is only 1. So it's only 2 significant figures. All right, well, thank you for watching.